Hey guys, Mr. Wood back to finish chapter 4. So good news, and that means next week we can wrap up lab and get ready for the test. And I'm not lying, the test is always a bit of a challenge. We've covered a lot of ground. We need a couple of jokes today. Why are opera singers good sailors? Did you know that opera singers are good sailors? Because they know how to handle the high seas. Why couldn't the pirates play cards? Because the captain was standing on the deck. And why did the doctor lose his temper? Because he didn't have any patience. There we go. Those are the jokes for today. Okay, so I've written on the board here, if you guys can see this, this is the plan coming up to the next 2 weeks. So this is got a lot of grades going on here. So Monday, Tuesday, we're going to finish the Redox titration lab. Cohort A, I posted, this is a 2-part lab. I did the first part with my period 4 cohort B today. And I posted it. We're going to use their data. So you need to look at that. And I did some more problems too from stuff that we had been over previous lessons. So there'll be time for questions on that day, be it the gravimetric lab or the quiz for chapter 4. And then on Wednesday, Thursday, it's really going to be a prep time. It's going to be time for you guys to work on the lab, the quiz, the textbook problems, and I'm more than happy to help you guys. We'll talk about the test. And then the gravimetric lab will be due on Wednesday, Thursday, and then the following week, on Monday, Tuesday, the quiz for chapter 4 will be due, and we're going to start the test. And then Wednesday, Thursday, the Redox titration lab will be due, and we'll finish the test. But we'll get into chapter 5. And from now on, we will cover chapters and have tests much quicker. We're kind of at the end of review and going into new stuff. But it's gonna change. We're going to start going through stuff and having tests much quicker than we did before. Okay, so here we are back to what we were talking about. I'm just going to do one more kind of a tricky redox titration problem. Okay, so where we were on this slide, and I've done some in class now, or I've done quite a few on video. There's definitely some in the book as well. This one at the very bottom is so complicated. I'm not going to do it. You can try it, and I'm more than happy to show you what I got for it. But I'll tell you what, I'll even give you the answer here before I do the next one. So that one at the bottom, it's a very complicated one, and I'll kind of get you started on it. But just for the sake of time, it's a little bit more advanced than the one that you need to be able to do for our class. Here is one I want to do with you, or I want to do 2 more with you that are more reasonable. So let me just do a couple more. So here we go. On this one, let me tell you what, let me try and remember here. So let's go back. Now here is one that I think is much more reasonable kind of problem. So we're going to balance using the half reaction method. And here's the first one. So this one's not written down in the notes, but we've got H plus zinc plus VO3 negative, VO positive 2 plus zinc positive 2 plus H2O. Okay, and I look at that, almost always hydrogen and oxygen are not the ones that are being oxidized and reduced. So I can see zinc here is being oxidized. And if I look at this with the vanadium here, -2 is +4, and here vanadium, so here's +4, and here -2, it's +5. So vanadium is what's being reduced. So my other half reaction here then would be this. So I'm probably being a poor role model for you here, but just trying to show you, usually the elements that are not going through oxidation reduction are usually not the hydrogen and the oxygen. Okay, so balance all the other elements other than oxygen and hydrogen and zinc and vanadium are balanced. Then I balance oxygen with water. So I'm going to put 2 waters here. So that's 2 oxygens and plus 1 makes 3. And there's no oxygen there. Then I balance the hydrogen with H plus. So 4H plus, 4, and again, no hydrogen there. Okay, and then I balance the charges. This is where I always mess up. So 4 positives and 1 negative, so a plus 3, and this is a plus 2. So I need 1 electron here. And over here, I need 2 electrons. Okay, so there's everything. Now remember, I want to get the electrons equal on both sides. So if I have 2 electrons here, I need 2 here. So I'm going to multiply this whole thing through by 2. So 2, 8, 2, 2, 4. Okay, now I'm going to add this up. So the 2 is going to go away. And what I'm left with then is the 8 H pluses plus the zinc plus the 2 VO3 negative. And then on this side, I have the zinc plus 2 plus 2 VO positive 2 plus 4 waters. Okay, so there it is. Again, just practice on these half reactions, which I think is new for most of you. Okay, now here's another one. Okay, this is what I had in the notes. This one's really an unusual one. But here, assigning oxidation numbers, here hydrogen is plus 1, but this is a peroxide. Whenever you see O with a subscript 2 in a compound, that's when oxygen's a negative 2. And then here, hydrogen's a plus 1, oxygen's a negative 2, and oxygen's a 0. And if you look at this, you go, wait, oxygen is being reduced, yes, and oxygen is being oxidized. So in this problem, like I said, it's a very unusual one that does happen. So if I write this out following the same method that I use, so I write out here the reduction, and then here the oxidation. Okay, so I go through my steps. So there's no elements other than H and O. Okay, and then I balance oxygens with water. So there's 2 oxygens here and 1 here, so I need another oxygen. Okay, and then I balance the H's with H plus, so I need 2 H plus. And then finally the electrons, I need 2 there. So I'm still doing the same thing. It's just a more complicated way to one that compared to one that you guys would have done easily before. And now the oxygen is balanced, so I need 2 H plus. Balances the H's, and then I need 2 electrons to balance the charge. So that goes away. That goes away. And what that leaves me is 2 H2O2 makes 2 H2O plus O2. And again, that one, you're going, I didn't need that. Okay, let me give you, here's this one, which is a very complicated one, and if you really want to challenge yourself, you can try this one. Okay, so this is the one I said in the notes, and actually, if you do this right, you actually get to where you have a coefficient of 72. But this is the final. This is the final answer that I get here. I have 18 waters, and I'm more than happy if we're going to have some work time next week, and if you want to go through this one with me, I'm more than happy to do it. But just for the sake of time, it's like pretty advanced. So I've got 18 waters, 3 P4s, 10 IO3s, 10 I negative, 12 H2PO4 negative plus 12H plus. So again, if you guys wanted to look at that, you certainly could, and it's definitely a So you can see it. Definitely an advanced oxidation reduction problem. So you might want to look at that. Okay, so now there's one other problem which is very, very similar to the redox titration lab. So let me go on in the notes. Okay, so we're definitely now at the place where we're doing new stuff. Okay, so we've done this page. Okay, and this is a page that I always tell my students that you got to memorize this. You got to memorize these two. And that the thing that you'll see later on with acids and bases in the winter and spring is we always add to them an indicator, which indicates an acid or base by the color. But the neat thing about a redox reaction is the color kind of shows you the titration. And if you today on cohort B, and then what I placed online, the second one, the MnO4, you saw, I remember I was trying to get it light pink. So the purple disappeared in a light pink, and that's when it was, when, like it says there, they both reduced and changes colors when all the reactant is consumed. So it acts as its own indicator. So these two you got to put in your brain, and I'll be honest with you, the most common one is the MnO4, the one we're using in the lab, the one that's going to be on the next problem. But these you need to remember. So redox is kind of neat because their indicators actually right within the chemistry of it. Okay, so here's the last problem for this chapter. So good news, and this chapter has been a monster. But 1 gram sample of plant material containing oxalic acid. So it's got oxalic acid, but it's got other things in it too. Is titrated with 24 mils of a 0.0100 molar KMnO4. Determine the percent by mass of oxalic acid in the plant. Okay, so let's go through this. And this is the last page. Okay, so what we're going to do is a lot of times where we start is we're going to write out the equation for what's going on here. So I need to do the half reaction. And there's one, I'll be honest with you. It seems like I've said this all the time, but after you take the first test, you'll have to tell me if I'm lying to you or not. But there's a reaction just like this. And first of all, one thing that gets confusing, and if you don't practice these, is the spectator ion. So KMnO4, when you put it in solution, it does this, and the K is a spectator ion. The K you ignore. The K, and that happens a lot throughout our class for K and Na especially. So here are my half reactions. So this is what I was just saying, one that you needed to remember. Okay, that was on the last slide. And the other half reaction, and on the day of the test, I will tell you this. So there, that one I'll write on the board because it's going to come up on the next test. And it actually, this is the reaction that we use in part A of the redox titration lab. Okay, so I need to write out the equation. So, okay, so I need 2 carbons. Mn is balanced. Okay, then I balance the oxygens with water. So I have 4 waters here. So that balances the oxygen. Here I have 4 oxygen, so we're good. Then hydrogen, so I have 8. So I have 8 H pluses. Here I need 2 H pluses. Okay, and then I balance the charge, and this is where I always make a mistake. So +8 and -1 is +7 and +2. So I need 5 electrons here to balance the charge. And here I have +2, so I need 2 electrons there. Okay, and then I want to balance the electrons, so I'm going to multiply. I want to get 10 because I have 2 and 5, so I want to get 10 on both sides. So I'm going to multiply everything here by 2. Okay, and I multiply everything here by 5. And that way what I've done is I've balanced the electrons. So the 10 electrons go away. The can get this down to 6. Okay, so what's left over then is 6H plus 2 MnO4 negative plus 5H2C2O4 makes 2 Mn plus 2 plus 8 waters plus 10 CO2s. Okay, I need that. Now, the question here is we're trying to figure out how much oxalic acid there is. So grams of this. And we are told, and again, I'm ignoring the K. The K is a spectator ion. So we have 24 mils of a 0.0100 molar solution. Okay, so now we're just stoichiometry, and hopefully now it's going to make more sense once I have the equation. So I can figure out, again, I'm trying to solve for grams of oxalic acid. On the lab, this is a hydrate, but here it's not. Listen, and I think on the test it's a hydrate again. I can't remember. I will tell you. Okay, so moles is going to be molarity times liters. So I'm going to take 0.0100 molarity times 0.0240 liters. So I get 2.4 times 10 to the negative 4th, really get my sig figs right, moles of MnO4. Okay, now I can do stoichiometry. So it's 2 to 5. So I have 2 MnO4s for 5 H2C2O4s. And then I'll find the mass of the oxalic acid. So let's see, the molar mass, let's see, 24, 26, 64, 90. And what I get there is 0.054 grams of OA, oxalic acid. But the question here was the percent. So I'm going to take the 0.054 grams and I'm going to divide by 1 gram total. It said 1 gram of plant material gives me 5.4% oxalic acid. So what we're doing here is we're really doing stoichiometry. We just had to come up with the equation to do that. So we're definitely in the mode now of doing some pretty good AP chemistry problems. Okay, hopefully that helps. I'm going to give you a couple, just some review sheets, but you can be working on the quiz, the lab. All these will help you get ready for the test. So guys, have a good weekend. Go Nuggets, go Broncos, and I will see you Monday, Tuesday. We'll finish that lab. Bye.